In this video, I am going to discuss about projection from a height. In the previous video, already I have discussed here when a body is projected at an angle theta from the ground. But here, let a body is projected from the point O, which is at a height h above the ground, with velocity u at an angle theta. इसका मतलब कोई बॉडी इस पॉइंट ओ से प्रोजेक्ट किया गया और वो पॉइंट ओ ग्राउंड पे ना होकर के एच हाइट पे है एंड फ्रॉम हियर द बॉडी इज प्रोजेक्टेड विद द वेलोसिटी u which makes an angle theta with the ground. So now in this case the component of u along this direction is u cos theta and the component of u in the vertical direction is u sin theta. And now our aim is to find what is the time taken by this body to reach on the ground. It means what's your aim first to find out the time of flight in this case, as well as when the body will reach at the ground, suppose at the point B, then what is the distance from A to B, means which is also called what here a range. So here I will give you the expression for how can we calculate the time of flight and how can we find the range of this projectile. In this case, for finding the time of flight means time taken by the body to reach on the ground. And when the body will reach on the ground, so you look here in this case what you will do. At the point O, vertical height is u sin theta. It means the body is moving with u sin theta in the upward direction. So you can take here, this body is moving in the downward direction with the velocity minus u sin theta. So from this equation, S is equal to ut plus half gt square. Simply ut plus half gt square. So for finding the time of flight, when you will consider this vertical velocity u sin theta in upward, but your aim is to find the time taken by the body to reach on the ground. So when you will take this u sin theta in the downward direction, then at place of this u, you will write minus u sin theta. And with this minus u sin theta, when the body will cover a height h, then you will write here h is equal to, at place of u, you can write minus u sin theta into t. याद रखिएगा u sin थीटा अगर प्लस होगा तो अपवर्ड है, लेकिन हमको नीचे की तरफ लेना है क्योंकि बॉडी कितनी देर में ग्राउंड पे पहुंचेगी, तो दैट विल टेक माइनस u sin थीटा इनटू t प्लस हाफ g t स्क्वायर. एंड इन दिस केस if h is known, u is known, theta is known, then by solving this one we can find the value of t, where t is what? This t is called the time of flight. Time of flight means time taken by this body to reach on the ground. So from this, the value of t can be calculated, and this we can calculate the time of flight. Second question that is here, how can we find the range of this projectile? The range means what is the horizontal distance covered by that projected body, and that horizontal distance is from A to B. It means the range of this projectile is the distance traveled by the body from A to B, which is r. So you can write the range of the projectile, the horizontal range AB, which is r, is equal to, and already I have told you how can you find the range of the projectile. What? Horizontal component of velocity into time of flight. And you know, at this point the horizontal component of velocity is what here? U cos theta. So you can take here u cos theta into time of flight, you can calculate from here. And when you will multiply u cos theta with the time of flight, then you can find out the range of this projectile. And remember this, if any body is projected from any height, so simply for finding the time taken by the body to reach on the ground, you will take vertical component u sin theta in upward, and in this formula s is equal to r, h is equal to ut plus half gt square. At the place of u, when you will take minus u sin theta, then in this way you will get the expression for time of flight, or the time taken by the body to reach on the ground. Now here we consider one special case. And what that is special case? Suppose if the body is projected from the point O, which is at height h, horizontally, it means this velocity u is along this one. So in this case, if the body is projected with this velocity u horizontally, it means here we will take, so here we will take the body projected from the point O, which is at height h, horizontally. इस बॉडी को हॉरिजेंटली फेंका गया, इट मींस एंगल फ्रॉम द हॉरिजेंटल, क्योंकि हॉरिजेंटली ही फेंका गया है इसलिए एंगल फ्रॉम द हॉरिजेंटल क्या हो जाएगा 0 डिग्री. और इस केस में हाउ कैन वी फाइंड द टाइम ऑफ फ्लाइट? इट मींस व्हाट इज द टाइम टेकन बाय द बॉडी टू रीच फ्रॉम O टू B. तो O टू B मींस हमने इसको हॉरिजेंटल वेलोसिटी दिया है, इसका मतलब इसका वर्टिकल वेलोसिटी क्या है 0. और ग्राउंड पे आने के लिए क्या होना चाहिए? जब ये हॉरिजॉन्टल वेलोसिटी इसकी 0 हो जाएगी तब वो क्या करेगा? वो ग्राउंड पे चला आएगा. इट मींस द टाइम टेकन बाय दिस बॉडी टू रीच ऑन द ग्राउंड, सिंपली इन द प्रीवियस इक्वेशन व्हिच आई हैव गिवन टू यू, देयर यू विल टेक थीटा इज इक्वल टू 0 डिग्री एंड देन यू विल गेट h इज इक्वल टू 0 प्लस हाफ gt स्क्वायर. Why I am taking here 0? क्योंकि ये वेलोसिटी u हॉरिजॉन्टल वेलोसिटी आपने दिया है और ग्राउंड पे आने के लिए उसके पास वर्टिकल वेलोसिटी ये होनी चाहिए थी. अब यहाँ पे इसका कोई कंपोनेंट नहीं है, क्योंकि यहाँ पे अगर थीटा पर आता तो u sin थीटा यहाँ लेते, लेकिन यहाँ थीटा 0 डिग्री है तो जब u sin थीटा लेंगे तो u sin 0 हो जाएगा. तो एवं इक्वेशन में जहां sin थीटा था वहां थीटा की जगह पे 0 कर दे, तो h is equal to you will get here 0 plus half gt square, or you can say 2h upon g is equal to t square, or t is equal to root 2h upon g. And in this way you can find out the time taken by this body to reach on the ground. और यहीं पे हम एक चीज और बताना चाहते हैं कि अगर दो बॉल को हम ले लें, if we'll take the two ball and suppose one ball is dropped from the roof of a building, एक बॉल को क्या करें उसके छत से फ्रीली फॉल करा दे, छोड़ दे, और दूसरे को हॉरिजॉन्टल फेंक दे. अगर पूछें कि which one will be reach on the ground first, तो in the absence of air you can say here both ball will reach on the ground together. दोनों ही बॉल जमीन पे एक साथ आएंगी. इसका मतलब यहाँ पे अगर किसी बॉल को हम हॉरिजॉन्टली फेंकें और उसी समय किसी बॉल को हम यहाँ पे फ्रीली फॉल करा दें, then the time taken by the both the ball will same to reach the ground. So in this way we will get the time of flight. And how can we find the range in this case? So range r is equal to, how can we find horizontal component of velocity? And what is the horizontal component of velocity? U into time of flight is what here t. So simply you can see here r is equal to u, and at the place of t you can write root 2h upon g. In this way you can find out the horizontal distance covered by the body when it is projected horizontally from any height h above the ground. Already I have told you when I have started this topic here, projectile motion. So on that time I have taken here the air resistance is negligible. It means in the projectile motion हमने air के resistance को ignore कर दिया है. But remember this, when we consider the air resistance, then at that time the height of the projectile means in the presence of air, the height of the projectile as well as the time as well as the range of the projectile both will be here affected here in the presence of air. So remember this, in the presence of air, height and range both will be what here affected. While in the other case you can say in the absence of the air, you can say height and range is more comparatively in the presence of the air. So dear student, today you go through this topic. This is very small topic what I have discussed here, and in this way you can say this chapter is completed. So you go through all the examples, short answer type problem, very short answer type problem of this exercise, and then you solve the numerical problem of this exercise here. So next time we will start the next chapter. Thanks.